Hey guys, so we're going to start this flow test off with the Airflow Research Enforcer manifold. This is the 4810 port match version, port matched to a AFR 195cc Enforcer CNC head for a small block Chevy. We're going to test it first, then I'm going to test the Hurricane and then the Super Victor 2. And then at the end, we'll do all the CFM calculations. Right now, I'm just going to get what the pressure drop is across the orifice at 28 inches of water, and then we'll do our math at the end to get the CFM and see which one is better off the shelf with no port work. And again, this is only testing with no port work. You can probably make one better than the other off the shelf with just a couple of adjustments, but we're just testing what the manifold is capable of, and whichever one is the best, if there's a clear winner, that's the one I'm going to start with, because that means it needs less work to become better. So turn your volumes down. I'm going to go ahead and do the flow test. And make sure you can see what I'm looking at. All right, here we go. Alright, so looks like alright. We got port stall on that. It didn't go anywhere. All right. That one's done. Now we're gonna set up the Hurricane. Blocking off these other intake ports. So I'm putting all of these to where the bolt holes are directly in the middle. Bias them in one way or the other. What that ensures is I'm not biasing the port in any way. Because see, I can lift this manifold up and get it closer to the roof of the port and actually pick up a little bit of flow, but I'm doing all of these to where the ports are as centered as they're going to be, to not skew the results and to maintain repeatability. So let's zero our pressure DP cell and we're going to start the next one. I did it off camera, but I put the tape on the other side here as to not influence anything. Next. So that's 200 thousandths of lift, and we'll work our way up. Next, that's a little high. I want to make sure these are as perfect as they can be. It's a little, with this being so tall, it's kind of hard to see. I guess this one's perfectly sized for mine, so be easier to tell. It's centered. Looks more right. Looks much more centered to me. Only thing I need to do is move the tape on these ports to these. Alright, and the last 0R pressure transmitter, DP cell. for the long video. So one thing we're looking at here is so these are the depressions. Without even looking at CFM numbers, I can tell you that at 200 thousandths lift, the AFR and the Super Victor had the same flow. The Hurricane was down. At 300 thousandths lift, the AFR and the Super Victor were not as good as the Hurricane. The Hurricane picked up a lot of flow at 300 thousandths lift and at 400 thousandths lift. And again, I think this is due to the fact that it's a smaller port. The airspeed is much higher, and it's not turbulent yet, but it is a much higher airspeed. So I think because of that much higher airspeed, you're getting a lot more flow here. So at 300 thousandths lift, it looks like the sorry, my camera keeps going to sleep and I can't see what you're seeing. So at 300 thousandths lift, it looks like the Hurricane had the best, with the AFR coming in second and the Super Victor still coming up short. So at 400 thousandths lift, this is kind of where my cylinder heads come alive. And so we jumped up to 3.35 on the AFR. The Hurricane jumped up to 355, which is quite a bit more flow than the AFR. And the Super Victor really woke up, and it jumped up to 3.6. And again, this is differential pressure in inches of water across the orifice. And I'll turn these into CFMs after, and then I'll just show them to you. So this is the, let's see, at 500 thousandths lift, both the AFR and the Super Victor were tied. They made the exact same amount of flow, and the Hurricane did not pick up as much. Started to get a little turbulent also. At 550 thousandths lift, the AFR picked up a touch. The Super Victor did nothing. It was dead nuts flat. Same with the AFR all the way up to 615 thousandths, and I did it all the way to 650 thousandths, and it made no difference at all. These numbers in the parentheses are at 650 thousandths of lift with the manifold, or with the throttle body, I keep saying manifold, with the throttle body installed at wide open throttle. If, as you can see, the AFR, it didn't care. It did not care that the throttle body was there. It changed nothing. The Hurricane actually dropped flow. It lost quite a bit of flow whenever I put the throttle body on at full throttle, which is indicative of the divider barrier not being good for port entry on that port. And then the Super Victor did not care. It was probably the one that cared the least. This one it was still 4.4 average. It was bouncing a lot more, a little bit more turbulent. Super Victor, smooth as glass, did not change at all. So at the end of the day, which one did the best? We'll average these flows, but the peak flow has to go to the AFR. I was not expecting that at all. I thought this Super Victor 2 was just gonna smoke them as far as high lift flow, but the little low rise AFR still flowed more air. It just did. The only place, and we'll turn this into CFM so you can kind of see the scale, but it was better at 1, 2, and 300 thousandths of lift. 200 thousandths lift, not really doesn't really matter. 300 thousandths lifts when things start really mattering. This is going to be a smaller port, so it's going to have a higher airspeed, so this is going to be more low speed torque. Your 400 thousandths lift, 335, which was way up on the Super Victor, which is more important. 400 thousandths lift is your most important. That's where you spend most of your time. And then 500 thousandths lift, dead nuts even, and then a tenth off of each other. Hurricane, you know, it never did get to 4.3, but as you could see, it was still trying to pick up some flow. But whenever I got to 650 thousandths from the 615, it did nothing, 4.2, and then I put the throttle body on and it dropped even more. So Hurricane, AFR Super Victor, good. Probably going to be low speed torque with this one, and you're going to have more more plenum volume in here, which is going to matter a lot for my turbo at full boost. This is going to have a lot more plenum volume, so this is the one that I'm going to use. But the AFR did not do bad at all, and honestly I would really like to flow the 4811, which is the high rise of this same manifold. That would be an interesting flow test to see what it would do against this one. However, at the end of the day, this is the manifold I'm going to use. The rest of them are going to go back. So let me get these CFMs calculated, and then I will come back on here. Okay, so ran the numbers. All right, 155 CFM, 149, 155, 200 CFM, 210, 196. So all within, you know, a little bit. The 210 here is much higher. That's 14 CFM more on the Hurricane over the Super Victor. Let's see, 400 thousandths lift, 229, 236, 237. So just barely any change between the Hurricane and Super Victor 2 on the at 400 thousandths lift. At 500 thousandths lift, 259, 245, 259. This is where the Super Victor pretty much flatlined. The AFR picked up, went from 4.4, this is the 4.3, so 262, and then it flatlined. So 3 CFM difference between the low rise AFR and the high rise Super Victor. And then if you start going down here, the differences don't really happen until about 400 thousandths lift. The Super Victor was better by, what's that, 8 CFM. And then at 300 thousandths, the AFR was a little better at 4 CFM more, and then the same at 200. So really, you know, plus or minus, the biggest difference here being 400 thousandths lift being, you know, 8 CFM greater on the Super Victor, and then only 4 CFM greater at 300 thousandths lift, and then only 3 CFM better up here in the high lift. So I was surprised at how close the AFR and the Super Victor were. Again, even the Hurricane it's down, you know, it's better down here at 300 thousandths than the Super Victor. 400 thousandths, it's essentially the same within 1 CFM. It's down, you know, 14 CFM here, and then only, you know, 6 or so. Yeah, it's very comparable. I think all 3 of these would perform very similarly off the shelf without a major change in the port work. You know, obviously low speed torque on the AFR is going to be better because it has less plenum volume, so airspeed is going to be a little higher. The Super Victor is going to, you know, have more plenum volume, so it's not going to have very good throttle response, but at the peak RPM it's going to really be able to provide enough plenum volume to continue on. And when the throttle body was at wide open throttle on the Super Victor, it completely unchanged. There was no restriction at all. This added no restriction. And then the air filter is going to affect them all the same. So same with this will affect it all the same. However, the reason why this affects them a little bit differently is because of how the port shape. And then you can tell that for sure when you put the Hurricane, you put this at full throttle, it tanked flow. So it got really turbulent because the airspeed just really shot up, and that's just because of that taper down to a very tight cross-sectional area. Anyway, that's the port flow. And then I'll do one more video with the cylinder head by itself, just so you can kind of see how much flow we're losing. I can tell you it flows around 300 CFM and all the ports. I mean, I hand ported these. Some are a little better than others. The best one's about 325 CFM. The problem I have is I go really turbulent above 615 thousandths lift. But again, with the cam I have and the lash that I'll have, 592 thousandths lift is what my net valve lift will be. So I won't even be in the 600 thousandths. And that's the reason I did that, because above 600 thousandths lift, it doesn't pick up any more flow. It just goes turbulent. If I can get the turbulence down, it picks up a significant amount of flow. But just due to my port shape, my minimum cross-sectional area, and how much room I have to move the port within these cheap heads, they're pretty maxed out. 325 CFM is pretty legit. We'll see what it is at 592 thousandths lift. I haven't actually done it yet since I took the heads off. So we'll see what that is together. Okay, so we're gonna flow just the cylinder heads with no manifold installed. I have my modeling clay here that kind of smoothens that transition. There's a little bit of a built up piece here at the bottom. The reason for that is the floor of my port goes down a little bit past the 1206 gasket. So I actually have this built up a little bit right here in a flat transition, because that's actually what the air is going to do coming off of that port in the manifold, because it's going to go to a kind of an open plenum area. So we're going to put that there. It doesn't really actually affect flow much, but just to make it as real as I could back to back, because when you have that gasket on there, it does affect the flow. So let's make sure you can see what I think you can see. Not that it really matters that much. We're just going to do some flow tests. So volume. I'll give you back when I get the numbers done. All right, so cylinder head flow 140, which is down. All the other ones with the manifold are higher, and that's just honestly due to taper in the port. At 300 thousandths lift, again, still down. The ports all have a little bit of taper in them, and they're speeding up the airflow. So still at 300 thousandths lift, without any manifold installed, flows less. This is where things take a huge change. At 400 thousandths lift, which is where my cylinder heads just straight up come alive. You got 258 CFM with no manifold, and the best one being the Super Victor 2 at 237. Okay, so you know, we're, what's that, 47, 57, so 21 CFM down now. And then 295 at 500 thousandths lift. You know, we can already see that we're significantly off, almost, you know, what's that, 30 something numbers. What's that, 295, so 59. That's, you know, 30 something CFM. Then you got at 550 thousandths lift, we're not picking up any here. And 262 is the highest we got on AFR, 309 CFM, and then at 600 thousandths lift, 310 CFM. And honestly, I just cannot get it to not be turbulent here. Whenever I can get it to stay stable, it's 325 CFM. However, I cannot get it to stay stable, so the air just backs up and CFM falls off a lot. So there you go. That's the comparison between old red cylinder heads and the Super Victor AFR low rise and the Hurricane. Send me any comments, questions you got. See ya. All right. So I just finished porting the, let's just say, I chose the Super Victor 2. Even though the angle on the roof is not ideal, let's just be honest, it's a badass manifold. It looks cool, and honestly, Old Red is not a race car. Even though I'm going to put a race manifold on it, it's just a badass looking manifold. I just couldn't not use it. So the AFRs are going back, world products, professional products, whatever the hell, it's going back. And then, yeah, Edelbrock Super Victor 2, we're keeping that one. I did some measurements and it should fit under the hood. So let's hope it does. So anyway, so the initial port work, you can't really see super good, but basically I thinned it out just at the very top just so I could open up these two port entries on the roof, because that's really where all the flow wants to be. I didn't really lay this back at all. I just kind of cleaned it up and made it even, because that's where the throttle plates are, so there's not really much to gain there. By gaining area as much plenum volume as we have with this manifold, slowing down airspeed is not a good idea, because it's already going to be a little laggy down low. So let's see what it did though. So here's the numbers. These are the old flow numbers, but I just already did the math. So 200 thousandths lift, basically the same. Gained a CFM, but I would say that's basically the same. At 200 thousandths or 300 thousandths lift, no change at all, still the same. At 400 thousandths, we started picking up some flow, picked up 7 CFM, that's pretty significant. At 500, we picked up 9 CFM. And if you remember before, at 500 thousandths is where it got to 259 and it did not move. it didn't care whether you put the throttle body on it or not. It was 4.3 inches of water, Delta P. But at 500, we picked up 9 CFM. And then at 550, it started to get turbulent and flow started backing up, but still higher than it was before. Got another 6 CFM. And at 600 thousandths lift, got even more turbulent, but it stabilized out. And we're plus 2 CFM, and then we lost a little bit at 615 thousandths lift. And this goes all the way up to 650 thousandths lift minus 4. Which doesn't matter. I'm pulling my, and that's why I didn't really care about this. My cam is going to 592 thousandths lift. So basically these mid lift 4, 5, and well, I say mid lift 3 to 5 is really mid lift, but 3 didn't gain anything. But between 4 and 550 thousandths lift, we picked up a chunk, and up to 600,000. So 4, 5, and 6 still picked up some flow. That's a significant amount of flow just from the amount of work that I have done. Next thing will be I'm going to have to adjust the minimum cross-sectional area by the push rod pinch point. I'm going to start doing some velocity testing and start seeing where the port velocity is, and start mapping out doing a port map of velocity around the circumference of the port, and start looking at the cylinder heads again, because the cylinder heads were optimized to the blower manifold that I had before, which was a terrible manifold, but the heads were optimized for that manifold. So now that I have a much better flowing manifold with a much longer runner, I can start taking advantage of opening up some areas in the port to slow down air and help with some of that turbulence. The heads want to flow a lot more than they are. Again, it flowed 310 CFM at 600 thousandths lift. And honestly, whenever I was able to get it to stabilize out, which was a very short period of time before it went turbulent again, it went up to 325 CFM. So if I can get it to get rid of that turbulence and pick up that additional flow, we may be able to get, I would really like to get in the 575 CFM plus with the manifold and the throttle body installed. That would be incredible. Anyway, that's where I'm at right now. The next video will be when I start doing some velocity mapping and pitot tube testing inside the port, and I'll try to do a video on that so you can kind of see what I'm doing and why I'm doing it. And we'll talk about what velocities you want to target in feet per second, and anyway, that's it. That's all I got.